Let's talk about hybridization. Now, hybridization is pretty simple. It's exactly what the word means in English. It's a combination, right? It's a combination of atomic orbitals. So you're literally combining atomic orbitals. Remember your atomic orbitals at this level, we just need to focus on your S and your p orbitals. So it's a combination of atomic orbitals of different types. That's your S and your P, right? That's it. That's going to be our focus. Now, the hybridizations that you will come into contact with at your level is the combination of 1s orbital and 3p orbitals for our sp3 hybridization, sp2 hybridization, and sp hybridization. These are the ones that you will come in contact with. So sp3 means you're combining 1s orbital and 3p orbital. sp2 follows suit. 1s orbital, 2p orbital. 1s orbital and 1p orbital, right? It's that simple. That's your sp3 hybridization, sp2 and sp hybridization. Now, if you can count the number of regions of electron density like we did earlier, you can determine your hybridization for any atom, right? So, for example, let's say you're given this molecule, ethane, and you are asked what is the hybridization on this carbon right here, right? All you need to do is count your regions of electron density on the carbon. 1, 2, 3, 4. Then go to your table. You're going to have to memorize these because this table is generally not given to you. So you're going to have to memorize the table, right? So you have 4 regions of electron density. Go to your table where it says 4 regions of electron density, right? And what's the hybridization? It's sp3. It's that simple. And anything that is sp3 has a bond angle of 109.5, right? Let's do another example. Let's say you're asked what is the hybridization of the carbon in formaldehyde. So you need the hybridization of that carbon. Let's count our regions of electron density again. 1, 2, 3. Remember your double bond is only one region, so we have 3 regions. Go to your table. 3 regions of electron density. We have a sp2 hybridized carbon, and your bond angle here is 120. Anything that is sp2 will be 120. Anything that is sp is 180. Anything that is sp3 is 109.5. Now, what do we really mean if you want to go into details? What do we really mean when we say that a carbon is sp3 hybridized? It's pretty simple. Remember in your carbon atom from we learned earlier, your 2s orbital and the 3p orbitals are in your valence shell, right? So remember we have your p orbitals in the x direction, the y direction, right? So there are 4 electrons in this valence shell, right? So this is what we mean by sp3 hybridization. It's the mixing of this 1s orbital with our 3 p orbitals. That's simply what happens. The valence shells mix. So let's mix this s orbital. So this is my 2s orbital. Then I'm gonna mix it with the 2px, 2py, and the 2pz, right? Now if you count, you will see we have 1, 2, 3, 4 orbitals in total. And what did I do to get these 4? I mixed 1s orbital with 1, 2, 3p orbitals. That's how you get sp3 hybridization on that carbon. That's what it means. And then remember from the valence shell, we only had 4 electrons, and these are degenerate orbitals. You put 1 electron in each orbital. This is how carbon formed 4 bonds, right? Because with the sp3 mixing, each orbital can accept one more electron. And that's what happens, for example, up here. The hydrogen has a 1s1 electron, right? 1s1, 1s1, and it's mixing here with a carbon. Let me use something simpler for this. So let's say we had this, right? And we have 1s1, 1s1. Each hydrogen has Each hydrogen brings in one electron to be shared with your sp3 hybridized carbon. This is your sp3 hybridized carbon. So each hydrogen will drop its 1s electron here. That's how you get that full octet. So the 1s and one of your sp3 orbitals combine here to give you this covalent sigma bond. So simply put, for hybridization, I was just simply telling you what sp3 mean. But if you get any atom and they ask you what's the hybridization, count the number of regions of electron density. And if you have 4, then it means you're mixing 4 orbitals, right? S, P, P, P. That's 1, 2, 3, 4. If you have 3, it means you're mixing 3 orbitals, and this is 3 orbitals being mixed. If you have 2, you're mixing 2 S and a P. This is pretty simple. The bond angles follow suit always. That's how you determine hybridization.